Alright, this is Math 111 OLC, winter 2012. Still in Unit 3. Today we're going to talk about Section 3.4, solving systems of equations in three variables. I refer to these as 3 by 3 systems. When you've got a 3 by 3, that means you've got three equations with three unknowns. I'm calling Section 3.2 and 3.3. We solve 2 by 2 systems. And so really this is just going to be an extension of what we've already learned in Section 3.2 and 3.3. Alright, Section 3.4. That's what we're going to start talking about today. Let me give you an example of a 3 by 3. Well, the usual syntax is to start out with x, y's, and z's. Housekeeping is so important in writing things down and algebraic manipulations. One little flub can send you off spinning into space. Alright, so I claim this is a 3 by 3 system. Basically, we've got three equations with three variables that I have to solve all three of these simultaneously. Now notice, these are already in standard form, and that's going to be the agreement, just to make our lives a little less hectic. When we're talking about 3 by 3s, we're always going to deal with them in standard form, and if they're not in standard form, we have to convert them to standard form. What I'm going to do is to solve a 3 by 3 system, what I'm going to do, and let me sketch out the solution technique. Well, I'm going to pick any two. Pick any two equations and eliminate a variable. And which one you choose to eliminate is often a matter of taste. Sometimes there's an advantage to eliminating one or the other, depending on the problem statement. Alright, and that is as we do in Section 3.2. And I'm going to say Step 2. Pick a different pair. Well, you've only got three to choose from, so at least one of them is going to be the same, right? One of them is going to be the same equation. Pick a different pair and eliminate the same variable. Alright, and if I do that correctly, I'll end up with two equations with two unknowns. The result from Steps 1 and Step 2 is a 2 by 2 system. Alright, then what I'll do is solve this as in Section 3.2. And then when I've solved for two of the variables, I can plug those two values into any of the ones I was originally given and then find the third with an easy substitution. Alright, let me show you how we're going to do this here. In this 3 by 3 that I've written down here already, 2x plus y plus 4z equals 12, x plus 2y plus 2z equals 9. Let me check this. 3x minus 3y minus 2z equals 1. Alright, let me consider Step 1. Let me erase this. I don't want to rewrite that system again. And I'm going to take equation 2 and equation 3 and eliminate the z's. So I'm going to write that down. Equation 2 plus equation 3. If I add these two, well, it seems like it's rigged that z will all automatically eliminate. So if I add those, I'll get 4x minus y. The z's cancel out, and I get 10. Looks better already. Alright, what I want to do now is pick a different pair, and again, at least one of them has got to be the same, and eliminate z from another pair. Well, I see if I take let's see, if I take equation 1 and add that to twice equation 3, again, the z's will cancel out. So let me make a note of that. I'm going to take equation 1 and add to that 2 times equation 3, and I'll get the resulting equation. Make sure I do this right here. I'll get, let's see, 2 times 3x is 6x, 6x plus 2x is 8x. And then y minus 6y is going to give me minus 5y. I'll take 4z and add to that 2 times minus 2z, and that's going to give me a 0. So the z's cancel out. And I'll take 12 plus 2 times 1 is 14. Alright, so basically I take two different pairs and rig things to eliminate the z variable from both. Alright, this gives me a resulting 2 by 2 system. Alright, and I'll solve this now as I've done before, as in section 3.2. I'm going to use elimination. I'm going to take this first equation and multiply it through by minus 5. So I get a minus, oops, erase that. Come on. That's an 8x. Okay. Let's try that again. I'm going to multiply the top equation through by minus 5. So then I'll get a minus 20x plus 5y equals minus 50. Let me make a note of that. Multiply by negative 5. All terms, both sides of that top equation in the 2 by 2 system. Why have I done that? Well, of course, you can see then if I just simply add the second equation, I'll get an elimination of the y variable, and I'll get a minus 12x equals, the y's cancel out, minus 36, and of course then x equals positive 3. Alright, if x equals positive 3, again I can go to either of these above equations and plug in x equals 3 and solve for y. I'll pick the second one. 8 times x, which is 3, minus 5 times y will then be positive 14. So 24 minus 5y equals 14, minus 5y equals minus 10, and y, of course, equals positive 2. Alright, so what I've got now is solutions for x and y in my resulting 2 by 2 system. So I still have to find z, and what I'll do is I'll just go up to my original problem statement. I can pick any one of these original 3 equations, plug in x and y, and easily then solve for z. Alright, I'm going to pick the first one, 2x plus y plus 4z equals 12. I know what x has to be. X must be 3. I know what y is. Y is 2. And z is yet to be determined. So 2 times 3 is 6. 6 plus 2 is 8. So 4z equals 12 minus 8. That's going to be 4. And of course then z equals 1. Alright, so really I've got a triplet, what I call a triplet solution here. X is 3, y is 2, and z equals 1. And typically variables are given in alphabetical order in order pair notation. So my solution to this 3 by 3 system is x is 3, y is 2, and z is 1. This set of coordinates will solve all three equations simultaneously. This will solve all three of the given equations. I won't burn up the video time to actually check a solution. Okay? Alright, so these can be a little long-winded, but it really is just an extension of what we already done in section 3.2. Let me do another one here. I'm going to get a fresh screen for each of these so I don't run out of room. Let's see. This one, let's see. Don't want to break down the same problem. Give me a minute here. Solve the following 3 by 3 system. 2x minus 3y plus 2z equals minus 7. X plus 4y minus z equals 10, and 3x plus 2y plus z equals 4. Again, this is a 3 by 3 system. 3 equations with 3 unknowns, and I have to solve for x and y and z simultaneously. Alright, I'm going to label these equations like I had before. And I notice if I add equations 2 and 3, I get an elimination of the z variable. Alright, so let me do that quickly. I'll get a 4x plus 6y equals 14. Alright, so that looks better. Now again, I'm going to want to pick another pair and eliminate the same z variable, so I'll get a resulting 2 by 2 system. Alright, so what I'm going to do is take the first equation and then add to it minus 2 times the third equation. Okay? Well, 2x minus 6x is going to give me a minus 4x. Okay? Then minus 3y plus minus 2 times 2y is minus 4y, gives me a minus 7y equals a minus 7 minus 6 gives me a minus 15. Let me do that again. It was a little crowded there. Let me try that again. Alright, I'm going to take my second equation plus the third equation. I can easily see that the z variables are going to cancel out. I'll get 4x plus 6y equals positive 14. Now I notice if I take equation 1 and add to that minus 2 times equation 3, well, equation 1 is 2x minus 3y plus 2z equals minus 7. Minus 2 times equation 3 gives me minus 6x minus 4y and minus 2z equals, say, minus 2 times minus 12. Hang on a minute. pause. Alright, so minus 6x, 2 times minus 3 is minus 6x, minus 2 times 2y is minus 4y, minus 2 times z is minus 2z, minus 2 times 4 is minus 8. And if I add these, I get a minus 4x, minus 7y, the z's cancel out, and indeed I do get a minus 15. Alright, so let me write that down here. I think the worst is over, because I see then the resulting 2 by 2 that I get is rigged to have an automatic elimination of the x variable. Alright, so no surgery needed in this second configuration. The 4x's cancel out. I end up with minus y equals minus 1, which of course means y equals 1. Alright, and if y is 1, what's x? Well, I can plug into any of those 2 by 2 equations. I'll pick the first one. Then 4x plus 6 times 1 equals 14. 4x equals 14 minus 6 is 8. And of course that means x equals 2. And then I can go above to any of the 3 by 3 equations, plug in x and y and solve for z. I'll pick the second one. And it should work out even no matter which one you pick. The solutions must work in all 3 of the equations. Alright, so when x is 2 and y is 1, I get 6 minus z equals 10, minus z equals 4, and of course then z equals negative 4. Alright, so when y is 1, x is 2, and z is minus 4, and again, if you're going to put your answer in ordered pair notation, we usually put the variables in alphabetical order, namely x, y, z. This is my simultaneous solution to all 3 of the given equations in ordered pair notation. Okay? Alright, I'm going to do one more. Let me get a fresh screen again. Housekeeping is so important in these problems. One little mistake could send you off. So be careful out there. I believe this one's from the homework list. This is number 21 on page 273. And let me write down. Be very careful here. Even just a copy error could send you tearing your hair out for hours. Alright, so here's the 3 by 3 system we are asked to solve. Equations 1, 2, and 3. Alright, if I view this, I don't think I have to look at it too long to realize when I add equations 1 and 3, I can easily eliminate the z variable. So let me make a note of that. 1 plus 3. Alright, I'll get a 7x plus minus 5y plus 7y is 2y. The z's cancel out. And I get minus 52 plus 31 is negative 21. Okay? Alright, so I rather easily eliminated the z variable using equation 1 and 3, and I think I see if I can multiply equation 2 by 2, I'll get a minus 8z in the z slot, which I can then easily use equation 3 to eliminate the z variables from that pair. So let me write this aside here. I'm going to take 2 times equation 2 and add to that equation 3. Alright, let me take my time here, do this real nice. 2 times equation 2 is going to be 4x minus 6y minus 8z equals minus 52. And if I add that to equation 3, I get 3x, let's see, plus 7y plus 8z equals 31. The 8z's will cancel out, and I'm left with 7x plus y equals negative 21. So that's going to be the second equation in my 2 by 2. And of course above, out of screen, is the first equation I'm going to use in my 2 by 2. So let me take those two equations and write down my new 2 by 2. I'll say 7x plus 2y equals minus 21. And again, just because I got a new screen here, I'm going to say that's equation 1 plus equation 3. And then if I take 2 times equation 2 and add that to equation 3, I get a 7x plus y equals minus 21. Okay? Alright. Of course, I see with a little bit of an adjustment, I can eliminate x very easily from these two equations. If when I add them, I'm going to multiply the top equation through by negative 1. I'm going to leave the second equation alone. Of course, the x variable cancels out. I get minus y equals 0. And of course, if negative y equals 0, then y equals 0. Alright. I can then use either of these above equations. Once I know y is 0 to solve for x, I'll use the second one. 7x plus 0 must equal minus 21. Well, that means 7x equals minus 21. And of course, then x equals negative 3. Alright, so when x is minus 3, y is 0, and I have to then ask what's z. And of course, what I'll just do is go to any one of my original 3 equations, plug in for x and y, and solve for the unknown z. Alright, I'm going to use the second one, 2x minus 3y minus 4z equals minus 26. Let me write that down there. Alright, when x is minus 3, y is 0. And I can use that information to solve for z. Minus 6. Well, 3 times 0 times anything is 0. Minus 4z equals minus 26. Adding 6 to both sides, I get negative 4z equals minus 20. And dividing both sides by negative 4, I get z equals positive 5. Alright, so my final solution for x, y, and z, simultaneous solutions in all 3 of those equations, is the coordinate minus 3, 0, 5. This triplet pair, this ordered triplet, I should say, will simultaneously solve all three of the equations I was originally given. Alright, it's a little long-winded, and you've got to be very careful. Again, any little mistake could throw you way off, and basically you end up tearing your hair out and starting again. So be careful out there in computing these homework assignments. I think I gave you about 9 of these in the homework list, and we'll call it a day. This concludes section 3.4 in unit 3, solving systems of equations in 3 variables.